Good morning, everybody. This is Miss Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Haliyar. In the previous class, we were discussing about how to solve the questions. What do you mean by Fourier series? And how to find the Fourier series, Fourier coefficients, how to recognize the odd and even nature of given functions. All these things we have discussed. We have discussed how to find the odd and even nature of given functions in the interval minus pi comma pi. So let's discuss few more examples in today's class. I had given two homework in the previous class. First question was find the Fourier series of the function f of x equal to x cube in the interval minus pi comma pi. This interval plays an important role because to check the odd and even nature for minus pi comma pi and 0 comma pi is different. Okay, to check the odd and even nature for this interval is different and this interval is different. That's why whenever we have given a question, we need to check the interval. So depending on the interval, we can find the odd and even nature. It is easy. There is nothing much difference. Solving the questions, formula, everything is easy. Okay, so let's discuss this question. Now they have said in the interval minus pi comma pi. In the interval minus pi comma pi, what do? We replace x by minus x. So it will be minus x whole cube. And we know minus x whole cube is minus x cube, which is negative of the given function. If it is negative of the given function, we can conclude that the given function is odd. We can conclude that the given function is odd. F of x is odd. If the function is odd, what can we conclude? If the function is odd, both the Fourier coefficients a0 and an are 0, and we need to find the value of bn. Remember that. If f of minus x is equal to minus f of x, we can conclude that f of x is an odd function. If f of x is an odd function, then the Fourier coefficients a0 and an are 0. I hope this much is clear to everybody. Then we need to find bn. First, let us write down the Fourier series expansion. It is a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin x. A0 and an are 0. We need to find only bn. So how do we find bn? Bn is given by the formula 2 by pi integral 0 to pi f of x dx. So this is the formula in order to find the value of bn. So what does it equal to? 2 by pi integral 0 to pi. What is f of x? F of x is given to be x cube. X is given to be x cube into dx. Next. What is it equal to? 2 by pi. What is the integration of x power 3? As said yesterday, integration of x power n into dx is x power n plus 1 divided by n plus 1. Here in place of n we have 3. So what is the integration of x cube? What is the integration of x cube? N is 3. 3 plus 1, 4 divided by 4, and the limits vary from 0 to pi. Limits vary from 0 to pi. Next, what do we do now? Let's substitute the limits and we can cancel out the terms over here. So we have 1 by 2 pi, upper limit is pi, so it is pi power 4 minus lower limit is 0. 1 pi get cancels, so what remains? Pi cube divided by 2. This is what? bn. Bn value we got it to be pi cube divided by 2. So let us substitute this. Is it okay everybody? Anybody has any doubt? I think we have missed out one term, isn't it?
Yes, ma'am.
Into sin nx.
Correct.
F of x sin of x.
The formula is f of x into sin nx dx. This is the formula for bn. 2 by pi 0 to pi f of x sin nx dx. So that is 2 by pi integral 0 to pi f of x is x cube into sin nx dx. We have to apply Bernoulli's rule in order to find the integral of product of two functions. We need to apply Bernoulli's rule. What does Bernoulli's rule? According to Bernoulli's rule, what shall we do? We should take the first and the second term. Algebraic term, let's take this as first term. Trigonometric term, let's take this as a second term. So according to Bernoulli's rule, what do? We'll keep the first term as it is, that is x cube, keep it as it is. Second term is sine nx. Integration of sine is minus cos, so we get minus cos divided by. Then alternatively positive and negative sign we need to give. First term was positive, so second term will be negative. We need to differentiate x cube. What is the differentiation of x cube? It is 3x square. After we differentiate the first term, we have already integrated one term. You need to integrate it once again. So integration of cos will be sine. Negative sign is already there, so it is sine nx divided by n. Previously there is one n term, so it will become n square. So it is done. Next, alternatively positive, negative, now positive term, differentiate this term. So differentiation of 3x square. Differentiation of x square is 2x and 3 is already there, so it will become 6x. Then we have to integrate this term again. Integration of sine is minus cos, minus of minus it will become plus cos nx divided by n. In previously we have n square, so it will become n cube. Next, so plus minus plus, again negative, differentiate 6x. Differentiation of 6x is 6 because differentiation of x is 1. That's why differentiation of 6x will be 6. Now integrate this. Integration of cos will be x divided by n. Here n cube already there, so it will become n power 4. Let me repeat this step once again. Why we are stopping till here? Because when you go to the next step, differentiation of 6 will be 0. So that's why we will stop it until we get a constant. Because in the next step we have to differentiate that term, and differentiation of a constant will be 0. So let me repeat this once again. In the previous class we have taken the question with respect to x square, where only up to 3 terms we used to get, but here we have x cube. So what we do is, listen to me carefully. According to Bernoulli's rule, suppose if we have to find the integral of product of two functions. Suppose if you have to find the integral of product of two functions, what you need to do is you need to take the first and the second term, and according to Euler rule, algebraic term comes first, trigonometric term comes second. So first term algebraic term, that is x cube. Second term is the integrate trigonometric term, that is sine. So take the first term as x cube, and according to Bernoulli's rule, first term keep it as it is. Integrate sine nx. Integration of sine nx is minus cos nx divided by n. Then you need to always give plus minus plus, alternatively positive negative sign. Then differentiate the first term. Always you need to differentiate the first term and integrate the second term. So differentiation of x cube is 3x square. Integrate minus cos nx by n. Integration of cos is sin nx by n. Negative sign is already there, so it is minus sin nx divided by n. Here one n is there, so it will become n square. Next, plus. Now differentiate 3x square. Differentiation of x square is 2x. So 2 into 3, it will be 6x. Now integrate this term. Integration of sin is cos, minus cos, so minus of minus will become plus cos nx divided by n, and previously we have n square, so it will become n cube. Then now negative sign, differentiate 6x. Differentiation of 6x is 6. Then integrate this, and integration of cos nx is sin nx by n, and previously we have n cube, so it will become n power 4. Next step we cannot do because differentiation of 6 will be 0. That's why we stop till here and we'll put the limits. Anybody has any doubt in this step? Bernoulli's rule. It needs to be done whenever you have the integral of product of two functions. This is the easiest way, or else you have to go for the method UV rule. Is it okay? Anybody wants me to repeat?
No, ma'am.
Okay, yes, let us done. Shall I continue?
Yes, ma'am.
Okay, now what shall we do? We should put the limits. And there are some terms which will become 0. See the limits. Limits are pi and 0. And we know sin n pi and sin 0 both are 0. So that's why this term is already 0. Directly you can put 0 because sin n pi and sin 0 values are 0. That's why the second term and the fourth term will be 0. And what else is remaining? Let us write down that. We have 2 by pi x cube into minus sign is there, so minus cos nx divided by n. Then we have the third term, so it is 6x by n cube into cos nx. Limits from 0 to pi. Now let us put the limits. Upper limit first. So upper limit is pi. What happens when you put the limit over here? It is 2 by pi, upper limit is pi. So replace x by pi. So we get here minus pi cube by n cos n pi. For this we substitute first. Upper limit is pi, so it is x has to be replaced by pi. So pi cube into cos n pi by n. Now put the lower limit 0. What happens if you replace x by 0? 0 into something it will be 0, so lower limit will be 0. So this is the first term. Now take the second term. What is it? 6 by n cube. For this upper limit is pi. So 6 pi cos n pi. So this is the upper limit for the second term. Similarly, when you put the lower limit which is 0, 6 into 0, it will be 0. So lower limit is 0 for both the cases. Now let us continue. What do we get over here? 2 by pi. Any common term we have over here? Minus pi cube by n cos n pi. What is the representation of cos n pi? Minus 1 power n. So cos n pi can be written as minus 1 power n. Next we have 6 pi by n cube. What is cos n pi? Minus 1 power n. Is it okay? Anybody has any doubt till here?
No, ma'am.
Anybody else? Cos n pi, always remember it's minus 1 power n. Cos n plus 1 into pi will be minus 1 power n plus 1. So it repeats. Cos n pi general representation is minus 1 power n. Depends on the value of n, whether it is even or odd. So done? Shall we continue?
Yes, ma'am.
Okay, now here
Yes, ma'am.
minus. So which is a common term? You can take out the common term here. Pi by n. So we have here 2 by pi which is already there. Pi by n into minus 1 power n. See pi by n minus 1 power n. Pi by n minus 1 power n which is a common term. So you can take pi by n minus 1 power n outside. So if you take that outside, what remains? Minus pi square. And here 6 by n cube. Am I correct? We have taken pi by n, so pi square remains. Here also, pi by n, it will be n square, correct? Is it okay? Is it okay?
Yes, ma'am.
Yes, ma'am.
Pi get cancels. What remains? 2 by n into minus 1 power n into 6 by n square minus pi square. So this is the value of bn. Anybody wants me to repeat anything?
No, ma'am.
Anybody else?
No, ma'am.
Anybody, any doubt?
Ma'am, you said sin 0 will be 1.
No, who said? Sin pi and sin 0. This you have learnt in your plus, isn't it? Plus 2 classes. Sin pi value is 0, sin 0 value is also 0. Cos 0 value is 1. And cos n pi depends on the value of n. Whether it is whether it is even or odd. If it is even, you will have plus 1 value. If it is odd, you will have a minus 1 value. Done? Uzma, is it okay?
Yes, ma'am. Yes, ma'am.
Anybody else? Praveen, Prashant, are you all listening?
Yes, ma'am.
So this is Bn. Now substitute in the standard representation. See, this is a Fourier series expansion. F of x is equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx plus summation n equal to 1 to infinity bn sin x. And as the function is odd, both the Fourier coefficients a naught and a n are 0. So this term and the second term, first and the second term, both will be 0. Only third term will be remaining, and in that we need to substitute bn, which completes the problem. So you have to write the entire step. Both a0 and an are 0, so you can start with n equal to 1 to infinity bn. Write down what is bn. 2 by n minus 1 power n 6 by n square minus pi square into sine nx. Is it correct? Amok, does this match with your answer?
Yes, ma'am.
Okay. So anybody has any doubt? Those who have solved this question yesterday, check. Done? Is it okay?
Yes, ma'am.
Anybody else has any doubt? This revision classes is for you all, especially for the lateral entry students. So listen to me carefully. Okay, I had given next one more question. Second question. F of x is given to be minus k in the interval minus pi less than x less than 0 and plus k in the interval 0 less than x less than pi. Here also you can see the interval is minus pi comma pi only. Interval is minus pi comma pi itself. Okay, so we have discussed how to check the odd and even nature in the interval minus pi comma pi. What we used to do, we shall take the first term as phi of x. What is phi of x? Minus k. And the second one as xi of x. What is xi of x? It is plus k. And just remember, this k is a constant. It does not depend on x. K is a constant, it does not depend on x. So let us check the odd and even nature. In order to check that, we need to replace x by minus x. What will be phi of minus x? I want the answer. What is
K,
phi
ma'am.
of k?
K.
Minus K, ma'am.
It is minus k. Why I said that first only? K is a constant. It does not depend on x. What we have to do, suppose if we have phi of x is equal to x square, phi of minus x will be replacing x by minus x. But here in this term there is no x term. This is a constant k. So where will you replace that x minus x by? Whatever may be the value of minus x, it remains the same because k is a constant. Phi of x is equal to k. It is a constant. It does not depend on the value of x. So whether you put the value of x as plus k or minus k, it does not alter the sign of k because x does not depend on k. It is an independent. Phi of minus x will be minus k itself, which is negative of xi of x because xi of x is plus k. We have got it here to be minus k, which is negative of xi of x. So what can we conclude from this? What can we conclude from this?
F of x is odd, ma'am.
F of x is an odd function. Anybody has any doubt in this? See, all these things I have explained in the previous class. Suppose if you have discontinuous function, take the first one as phi of x, take the second one as xi of x. Then to check the odd and even nature, you have to replace x by minus x. But this is a term which is independent of x. So whether you put x as plus or minus, the value remains the same thing. That is minus k, which is negative of xi of x. So phi of minus x is minus of xi of x. We can conclude that f of x is an odd function. If f of x is an odd function, we can conclude that the Fourier coefficients a0 and an are 0. Anybody has any doubt in this step?
No, ma'am.
Okay, why are we checking the odd and even nature? Just because of this, or else you need to put the value of a0 and an, substitute, and you have to check. In order to reduce the work, we are checking the odd and even nature of the given, which reduces lot of work. Because suppose if the question is asked for 6 marks and if you go on checking what is the value of a naught, what is the value of an, what is the value of bn, it is really time consuming. That's why the concept of odd and nature is introduced over here. So as we have got it to be an odd function, we know both the Fourier coefficients a0 and an are 0. Now we need to find only the value of bn. What is the formula of bn? It's 2 by pi integral 0 to pi f of x sine nx dx. This is the formula of bn. Done? Is it done?
Yes, ma'am.
Okay, so it is 2 by pi integral 0 to pi. I repeat once again, this is the formula. We have proved phi of minus x is equal to minus xi of x. That's why f of x is an odd function and both the Fourier coefficients a0 and an are 0. We have only three Fourier coefficients a0, an, bn. As it is an odd function, a0 and an are 0, so we need to find the value of bn. What is the formula for bn? 2 by pi 0 to pi f of x sine nx dx. So it is 2 by pi 0 to pi. What is f of x? Tell me what is f of x now. What is f of x?
Ma'am, your screen is not visible, ma'am.
To everybody or only to you? What about others?
Visible, ma'am. Visible, ma'am.
Visible,
Oh,
ma'am.
Visible, ma'am.
okay, okay. Just check your internet connection. Log in once again. You might have some internet connectivity problem. Log in once again. Check now. Now tell me. Others, you all tell me the answer. What is f of x?
K,
See
ma'am.
the k. Why it is k? It is 0 to pi. 0 to pi. Where does 0 up to pi? In the interval 0 to pi, what is f of x? It is plus k. That's why it is k into sine nx dx. Remember it is. Why it is k? Because limits vary from 0 to pi. That's why it is k. If the limits were varying from minus pi to 0, then it would have been minus k. So you have to take care here in this case, especially in the case of discontinuous functions. I expect everybody to attend my class hereafter. See, because I am going from the beginning of the second module. So that's why if you miss yesterday's class, at least you can watch the recording which will be available in YouTube. Okay. The very simple concept. If you do not attend the class from the beginning, you will not be able to understand what is happening in today's class. It's very clear. Understand this and keep this in mind. If you do not attend the class regularly, maths, you won't be able to understand. So now there is a chance for you all because all the sessions will be recorded and it will be updated in YouTube. So if you miss out any day's class, go to the YouTube channel and see the recording so that things will be clear because it is a continuation. It is a continuation. There is nothing which we will not be using what is done in the previous class. It is just like a series. Only the continuation will be broken when we are done with that module. Otherwise, the day what I teach will be applicable until I finish that module. So it's my request to everybody. Able to understand what I am teaching today, it's mainly because if you have not understood what I have taught yesterday. So try to make the concept, the first class, very clear. I have been going very slowly so that you should not say that you have not understood. I hope this is clear. Just put little effort on your studies and just study whatever I teach. Very much sufficient. You will never struggle to complete this paper or to clear this paper. Okay, so I hope this is clear. We are finding the value of bn. It's 2 by pi 0 to pi f of x sin nx dx. F of x is plus k because the limits are from 0 to pi. So limit 0 to pi f of x is k sin nx dx. Now you need not apply Bernoulli's rule because k is a constant. So you can take outside 2k by pi. Integral 0 to pi sin nx. Integration of sin nx. It is minus cos nx divided by n. Limits vary from 0 to pi. So you can take that n outside, minus 2k by pi n. Minus n I have taken outside, n also I have taken outside. So it is minus 2k by pi n. Anybody, any doubt? Okay. Then now put the limit. First limit is upper limit, replace x by pi. So it is cos n pi. Lower limit is 0, cos 0. Cos 0 is what? What is cos 0?
1.
Yeah, 1.
ma'am.
So what do we get over here? Minus 2k by pi n. Cos n pi is minus 1 power n. Cos 0 value is 1. So this is what? This is the value of bn. So a naught by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Function is odd, that's why both a0 and an are 0. So our Fourier series expansion is summation n equal to 1 to infinity bn. What is bn? You can also write it as 2k by pi n. Minus sign you can take out inside and you can write it as minus 1 power n into sin nx. So this is the Fourier series expansion of the function minus k and plus k. Is it okay, everybody?
Yes, ma'am.
Okay, so I hope this question I had given as a homework. If at all you have done, check with the answer. If it doesn't match, check where you have gone wrong. So done? Is it okay? So I hope hereafter you don't refer that long method to solve this as you have done previously. Okay? Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay. See, now we will be discussing with one question. I don't remember whether I've solved this or not. You just
I have a
can.
doubt in one question, ma'am.
Yeah, tell me, what is that?
That is pi minus x the whole square.
Huh. Tell me what is your doubt in that. Wait, let me write down. F of x is equal to pi minus x the whole square. In which interval? Tell me the interval. Huh?
0 to 2 pi.
Okay, so when I discuss 0 to 2 pi, you tell me. Okay? That time we will discuss this. Now we are dealing with the interval minus pi comma pi. So 0 to 2 pi we will do it tomorrow. That time you ask me, we'll do it. Okay? Yeah. So minus pi to pi, anybody has any doubt?
No, ma'am.
Okay. So I will discuss one question which lies in the interval minus pi comma pi, but it is neither even nor odd. Okay. So let us do that problem, and this has been repeated in December 16 paper. Okay. F of x is equal to x minus x square. We need to find the Fourier series expansion of this in the interval minus pi comma pi. Okay, f of x is equal to x minus x square. So yes, in the interval minus pi comma pi. So whenever a question is there, you can check. There is no problem in checking. So you check by putting x equal to minus x. So what happens if you put x equal to minus x? It will be minus x minus x whole square. You have to replace x by minus x. So what happens when you replace x by minus x? Here it will be minus x minus x whole square. So it will be minus x square. Correct? Is it same as f of x? It is not same as f of x because f of x is plus x. It is not equal to minus f of x also because if you take minus sign outside it will be x plus x square. But what is f of x? X minus x square. So what can we conclude from this? F of even nor odd. Am I clear? What did we do? We replaced x by minus x. Is it clear everybody?
Yes, ma'am.
Okay.
Yes, ma'am.
So we have replaced x by minus x. We got minus x minus x whole square. So it is minus x square, which is not same as f of x because f of x is x minus x square, which is not same as minus of f of x also because if I take minus outside it will be x plus x square. So which is neither even nor odd. So what we have to do? We have to find all the three Fourier coefficients a naught, an and bn. We need to find all the three Fourier coefficients. So let us write down the Fourier series expansion. It is a naught by 2 plus summation n equal to 1 to infinity an cos nx bn sin nx. This is the Fourier series expansion and the Fourier coefficients. How a naught is given by, see here, the very much you will be confused only here while writing the formula of a naught. It is neither even nor odd. So are you minus pi? This is where you get confused because in the previous example the function was once we got it to be even, once we got it to be odd, that time we write it as 2 times 0 to pi. But here it is neither even nor odd. That's why our formula is 1 by pi minus pi to pi f of x into dx. This is the change you need to remember. This is the standard formula. But when the function happens to be either even or odd, we write this as the one what we have minus pi to pi, we write it as 2 times 0 to pi. So that is the difference you should be able to make out. Remember only this formula. Remember only this one. But when you get it in the formula, it is an even or odd function, you have to do it as 2 times 0 to pi. So that is the changes you need to make. Is it okay, everybody?
Yes, ma'am.
Yes, ma'am.
So now here it's 1 by pi, limits minus pi to pi, f of x is x minus x square into dx. Let us integrate it. 1 by pi, integration of x. It is x power 1 plus 1 by 1 plus 1. So it is x square divided by 2 minus integration of x square. X square is x cube divided by 3. Put the limits. What happens when we put the limits? A naught is equal to 1 by pi into, first we put the upper limit. Are you all able to hear me?
Yes, ma'am.
Okay. Put the upper limit is pi. So when you put x as pi, it will be pi square. Then you put the lower limit, upper limit minus lower limit. So minus, lower limit is minus pi. So it is minus pi whole square. Then come to the second term. It is minus 1 by 3 into x cube. Upper limit is pi. So it is pi cube minus lower limit is minus pi whole cube. So we have substituted upper limit and lower limit for both the first term. First I have taken the first term minus second term. So upper limit minus lower limit. Now let us simplify. What do we get? 1 by pi into half times. So pi square minus pi square is what? Pi square itself. So pi square minus pi square, it will be 0. Minus 1 by 3 into what happens over here? Pi cube minus pi whole cube will be minus pi cube. So it will become plus pi cube because negative sign was there. Minus of minus, it will be plus. So what do we have over here? Minus 1 by 3 pi. Here is the pi. So pi cube plus pi cube is 2 times pi cube. 1 pi get cancelled. So we get minus 2 by 3 into pi square. This is what? A naught. A naught value is minus 2 by 3 into pi square. But therefore, what is the value of A naught by 2? Because in the formula we need to substitute A naught by 2. A naught is 2 minus 2 by 3 pi square divided by 2 on both sides. So we get minus pi square by 3. So this is A naught by 2. Anybody wants me to repeat? Or anybody has any doubt?
No, ma'am.
No, ma'am.
Okay, so we are done with A naught. Next we shall find AN. What is the formula for AN? It's 1 by pi minus pi to pi f of x cos nx dx. See this standard formula you remember. Suppose if the function happens to be even or odd, it will be 2 times 0 to pi. Okay, this is your standard formula. An equal to 1 by pi minus pi to pi f of x cos nx dx. So that will be 1 by pi minus pi to pi f of x is x minus x square into cos nx dx. Now you have to apply Bernoulli's rule. You have to find the product of integral of product of two functions. This is the first term and this is the second term. So according to Bernoulli's rule, what do? We keep the first term as it is, that is x minus x square, keep it as it is. Integrate cos nx. Integration of cos is sine. So sine nx divided by n. Negative of will be 2x. Now integrate this term. Integration of sine is minus cos. So cos nx divided by n, already there is n, so it will become n square. Done. So alternatively positive, negative, now positive. Differentiation of minus 2x is minus 2. Integrate this one. Integration of cos is sine, minus sine is already there. So minus sine nx by n, and 1 n square is already there, so it will become n cube. Is it okay?
Yes, ma'am.
Everyone.
Yes, ma'am.
So you need to come only till here. Okay?
Yes, ma'am.
And the next step is very easy. Check the limits, minus pi and plus pi. And we know sin n pi is 0. So here also sin n pi is 0. So first and the third term, forget it. Only write the middle term. So we get here, so minus of minus, it will be plus. We get 1 minus 2x into cos nx by n square. Isn't it easy? Just look at the limits and see the terms. Sin is there, so sin n pi is 0. Here also sin n pi is 0. Over. Only thing what remains is this term, which varies from minus pi to pi. So you can take the n square outside. So 1 by pi n square. Now put the upper limit, that is pi. So replace x by pi. 1 minus 2 pi into cos n pi. When you put the lower limit, it will be lower limit, upper limit minus lower limit. X is minus pi, so you will get 1 plus 2 pi cos minus pi, and we know cos of minus theta. Cos of minus theta is plus cos theta only. That's why cos of minus n pi will be cos n pi only. Is it okay? Is it okay, everyone? What I have done, substituted the upper limit minus lower limit. Anybody wants me to ask anything? Anybody wants me to explain anything?
No, ma'am.
Just specifically for you all. Any doubt you can bring here, we will do it, we will discuss this in class. There should not be anything, you should not say that you have not understood. Whatever may be the doubt, ask. If not now, you can ask me later on after the class as well. So whatever your questions, it will be discussed. Okay. So if it is clear, we will move on. Now you can try to cancel out few terms over there. 1 by pi n square. See what happens here. 1 cos n pi. When you multiply here, 1 into cos n pi and here minus 1 into cos n pi. Those terms get cancels. What is it here? Minus 2 pi cos n pi, and here also minus 2 pi cos n pi. Minus 2 pi minus 2 pi. It will be minus 4 pi cos n pi. Is it okay? When you multiply here, 1 into cos n pi minus 2 pi into cos n pi. 1 into cos n pi, the minus is here. So and minus 2 pi into cos n pi. Plus 1 minus 1 get cancels. Minus 2 pi cos n pi, and here also minus 2 pi cos n pi is remaining. So we will have minus 4 pi cos n pi. Here pi get cancelled. So what remains? Minus 4 by n square, and cos n pi general representation is minus 1 power n. Done. Now this minus 1 power 1 is there. So I can write it as 4 by n square minus 1 power n plus 1. Is it okay, everybody? Minus 1 power n1 is there. So I can write it as minus 1 power n plus 1 altogether. So this is the value of an. Done.
Yes, ma'am.
Okay. Next we shall find bn. What is bn? 1 by pi integral minus pi to pi f of x sin nx dx. That is equal to 1 by pi integral minus pi to pi. What is f of x? X minus x square into sin nx dx. Now let us apply Bernoulli's rule. So what is Bernoulli's rule? Bn equal to 1 by pi. This is the first term and this is the second term. So first term, keep it as it is. Integrate sine. Integration of sine is minus cos nx by n. Minus, differentiate this. It is 1 minus 2x. Differentiation of x is 1. Differentiation of x square is minus 2x. If anybody has any problem with, if you do not know how to integrate, how to differentiate, please contact me. I'll provide with the standard results. So you can remember that. If anybody has forgotten, especially the lateral entry students, if you have forgotten differentiation integration, please ask me. I'll provide you all the formulae. Then now integrate this. Integration of cos is sine. Negative sign is already there, so it is minus sine nx divided by n. 1 on n is already there, so it will become n square. Then plus differentiate. Differentiation of 1 is 0. Differentiation of minus 2x is minus 2. Now integrate this. Integration of sine is minus cos. So minus of minus, it will become plus cos nx. N square is already there, so it will become n cube, and the limits vary from minus pi to pi. Now again you can see the limits, they vary from pi minus pi to pi, and sin n pi is there. So the middle term will become 0. Directly you can put 0 because sin n pi is 0. However, when you put the lower limit and upper limit, it's going to be 0. So you need not worry about it. Whatever terms which are remaining, just write it down. It is x minus x square. Minus sign is already there. Here there is a minus sign. Cos nx by n, and the third term it is minus 2 by n cube cos nx. Upper limit is pi, lower limit is minus pi. Now let us substitute the limits. What we get when we put the limits? 1 by is pi, by pi square cos n pi by n. Let us put the upper limit first. Minus 2 by n cube cos n pi. Once I put the upper limit to the entire term, pi minus pi square cos n pi by n minus 2 by n cube into cos n pi. So this is what? This is the upper limit. Minus, now the lower limit, minus pi. So when you replace x by minus pi, it is minus pi minus x, you have to replace by minus pi. Minus pi whole square is pi square itself. So cos n theta, I have told cos minus theta is plus cos theta itself. So it doesn't matter what value of pi x you replace by, it will be cos n pi by n minus 2 by n cube into cos n pi itself, because cos minus theta is minus cos theta. Now you can see here some of the terms get cancelled over here. You can cancel those terms. What are the terms which get cancelled? Tell me which terms get cancelled.
Pi, ma'am. Cos n by n, ma'am. Cos n.
Okay, what is remaining? That you all tell me. See here. Minus pi by n cos n pi, if you take this term cos n pi, and here you have minus of minus plus pi square cos n pi by n, and here you see minus minus minus, so it will become negative pi square by cos n pi by n. I hope it is clear. See this term, you consider this term, and here is the term. This two get cancelled because here there is a negative sign. Minus of minus plus pi square cos n pi by n, and here you have minus minus minus, which is minus pi square cos n pi by n. So this term here get cancels. Then you can check over here. See, this is minus 2 by n cube cos n pi, and here you have minus of minus. This negative is only for this one. You have minus with this minus, which is positive. So plus 2 by n cube cos n pi and minus 2 by n cube cos n pi. These terms get cancelled. Now tell me what is remaining. Here it is minus pi 1 by pi into minus pi by n into cos n pi, and here also you check this one, minus minus minus, which is minus pi cos by n, and pi by n is a common term which you can take outside. Actually minus pi by, and 1 pi is already there, so minus pi minus 1 by n into 2 times cos n pi, because cos n pi plus cos n pi is 2 times cos n pi. Is it okay? Here calculation is little more is there, for that you need practice. You practice this question today. So what we have, cos n pi, you can replace it by minus 1 power n. So it will be minus 2 by n into minus 1 power n. Or else you can combine this minus sign and you can write it as 2 by n into minus 1 power n plus 1. So this is the value of bn. Practice this question. This is little complicated over here when you find bn. So finally you have to write f of x. F of x is what? A naught by 2. We have found a naught by 2, that is minus pi square by 3. So substitute over here. It is minus pi square by 3 plus summation n equal to 1 to infinity an. What is the value of a? There it is. 4 by n square minus 1 power n plus 1. 4 by n square minus 1 power n plus 1 into cos nx plus summation n equal to 1 to infinity bn. Bn is here 2 by n minus 1 power n plus 1 into sin nx. So this is a Fourier series expansion of f of x equal to x minus x square. This is asked in December 2016 paper. Practice this question. Okay. So if you have any doubt, you can ask me in the next class. Okay. Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay, ma'am.
So I'll give one more question. You can work out this question. It is also from the interval. See, this is asked in twice. This question is asked twice in June 17 and December 18. Find the Fourier series expansion of f of x is equal to mod x in the interval minus pi comma pi. This I have discussed in class. This question is being discussed, but practice without seeing the notes. So if you get any doubt, go back to the notes and check this question. Is it okay? This is
Okay,
the
ma'am.
homework for today. This is the
Okay, ma'am.
homework for today. And tomorrow we will begin with the Fourier series expansion of functions with a period 2 pi in the interval 0, 2 pi. So till now we were discussing about minus pi, pi. Tomorrow we will discuss in the interval 0, 2 pi. This question you have to work out because I have already explained once during the regular class. So if you have any doubt, you can ask me. But this question practice today after the class or before my next class, that is tomorrow evening at 3 o'clock. Everybody be present for that class because tomorrow I'll be explaining how to find the odd and even nature in the interval 0, 2 pi. Also, we will be discussing how to solve those questions. So please attend the class. Don't miss that class. Done? If you have any doubt, you can send me your doubts. We'll discuss that. Okay? Send me that doubt. We'll discuss that in the class. Okay, thank you everybody. We'll meet in next class. That's tomorrow at 3 o'clock.